Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy, very Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Entropic Triangles by Signe, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have entropic lines, where any set of 3 digits along the peach lines must contain one small digit, which is 1, 2, or 3, one medium digit, which is 4, 5, or 6, and one large digit, which is 1, 7, 8, or 9. So as an example, to fulfill this criteria along these 3 cells, you could have something like 6, 9, and 1, and this would be valid because all 3 of these cells, in these 3 cells, you have one low digit, which is 1, 2, 3, one medium digit, which is 6, and one high digit, which is 9. So that's an example of how part of an entropic line, and again, this is for any 3 cells along an entropic line. So you have to satisfy that criteria. That's an example of how entropic lines work. We also have German whisper lines, where any adjacent digits along a green line must have a difference of at least 5. So for example, if this were say a 3, this would have to be 8 or 9 to be, because those are the only digits which are 5 or more away from 3. So that's an example of how German whisper lines work. And finally, we have quadruples, where digits in a white circle must appear in one of the adjacent 4 cells. So around this circle, there must appear 1 in one of the 4 adjacent cells that are surrounding it. And around this circle, there must be a 9. So that means the 9 must appear somewhere in the 4 cells that are surrounding that circle. And those are all the rules. I chose this because it was interesting because this sort of demonstrates how entropic lines, or basically any line that has 3 sets which you alternate between, how it sort of works. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So here, we know this, well, we don't know that much thinking about it. This digit here, let's start here. This digit here is next to 3 other unique digits on a German whisper, or as I like to call them, whisper 5 lines, because whisper 5 is clearer about how it interacts, right? There are also things known as Dutch whisper lines, but the thing is, it doesn't really extend further. I don't really know like how you, so it doesn't extend very well, right? So it's like, what's the line that has to have a difference of at least 3, right? What's the line that has to have a difference of at least 6? What's the line that has to have at least a difference of 9? Which I've seen, they called it a silence line, which is interesting because there's no whispers normally. But anyways, so I like to just basically call them like whisper number line, because then it makes it very clear what type of, it's a whisper line, and there has to be a difference of at least that number, right? So that's why I call them whisper 5 and whisper 4, whisper 3. It's very simple, right? Whisper 1, whisper 2 lines. Whisper 1's kind of, it's given, right? Actually, it's not necessarily true. You could actually have diagonals along the whisper lines too. So anyways, I call them whisper 5 lines because of that. Well, this digit is next to 3 other unique digits on a whisper 5 line. So it must be either 1, which can be next to 6, 7, 8, 9, or 2, which can be next to 7, 8, 9. But 2 of these digits here are of different sets. So one has to be either medium or small, or medium and large definitely, right? Because you can't have you can't have them be small and large, because if one's small and one's large, what digit is going to be 5 away from both of those? Well, the most extreme is 1 and 9, but there's no digit that could be next to both of those that's 5 away from both of those. So, one of these is guaranteed to be medium, and one of them is guaranteed to be the other, either small or large here. So this is going to be one set. We're going to make that, I don't know. We'll make that orange. And these two must be other sets. We don't know which one. We're going to make this one pink and this one yellow. That means this set cannot be the same as either of these, so it must be the same as that set. Also, this digit then has to be next to a medium guaranteed. That means it's 4 or 6. Well, 4 and 6 can only be next to 1 or 9 on a Whisper 5 line, and actually can only be next to one digit. So if this were 4 or 6, that's not possible because it's next to 2 unique digits on a Whisper 5 line. So this has to be the medium. So this is definitely medium here, and is 4 or 6 next to the 1 or 9 here. So how does that work? I don't think that works. So this must be medium, other medium, right? Because we're missing a medium in this set of 3. That can't be right. Huh. Because it would have to be the same medium, right? Oh, no. These are the... Okay. Yes, no, that works. So then this is green. So you have medium, some other set, it's either low or high. This is low or high, and this must be medium, right? Because every set of 3 digits on an entropic line must be have one from every set. And the reason, and so you know every third cell on the line will be the same set, right? So this will be the same set as this, because these two must be different sets. And for this to have 3 sets of digits that are the same, this must be, one each of the 3 sets. This has to be the same as that one. So this also has to be 4, 6, because it's on the Whisper 5 line. 5 can never be on a Whisper 5 line, because if you subtract 5 from 5, you get 0 or less. And if you add 5 or more to 5, you get 10 or more, none of which are normal Sudoku digits. So if you have 4, 6 here, you have 4, 6 here. This must be the other 1, 9, and it must be the opposite set as this one, right? So this cannot be the green set, because if it were, it would have to be a 5, because we have a 4, 6 pair already in that box. So this must be not orange, because orange and orange can never be 5 away from each other. So this must be pink then, to be 5 or more away from 1 or 9. Which means in this triangle, where's the green? The green has to be here, and therefore this is a 5. So now we have every third digit on this triangle available, we know, is a middle digit. So we have middle. This is orange. So we know what these are. So this is orange, pink, green. So then we have to find on this triangle, orange, pink, green. Then we have orange, pink, green. And then continue along this triangle. Orange, pink, green. Let's just do now all of them. 1, 2, 3. 1, 2, 3. So we have, these are orange, these are pink, and then these are green. So we have that. Same with this one. We have orange, orange, I guess orange, pink, green that way, right? So orange, this is pink, this is green. So we have oranges, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 are oranges. These are 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 are pinks. And 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 are greens. So we have a similar setting here. This is green here. So this is 4 or 6, which is next to a 1 or 9 here. And this 1 or 9 is next to the pink. And these can't be both pink because, again, pink and pink are never going to be 5 away from each other. So this has to be orange. This is orange. This can't be pink either because it can't be, again, pink and pink cannot be 5 away from each other. So it can't be orange. So this has to be green, which makes this the 4, 6 green, which makes this the pink 1, 9 also to be next to it. So we have the coloring for this triangle now. So this has to be pink to fulfill the 3 cells here. Orange, pink, and green, which makes this the 5. This is orange again. So orange, pink, green, orange, pink, green, orange. So we have orange, orange, pink, 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 and then green, green. Okay. Well, in this lower left-hand box, we now have 3 oranges and 3 greens. That leaves this as pink here. In this central box, or this left central box, we have 4 greens and 4 pinks, so this must be orange. And in this lower right-hand box, or this lower central box, we have 4 oranges and, 3 oranges. Did I say 4 previously? It's always 3. 3 oranges and 3 pinks, so this must be green. Okay. Let's see. What else do we have? Do we have anything else? This cell we have, in this upper left-hand box, we already have 3 pinks and 3 oranges, so this is green. So that means every third one then is green along this triangle. So this must be green. 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, obviously. So this is green. These are all green. We don't know what these are. It's one of each, but we're not sure which. So this is green, which makes this a 4, 6, which makes this 1, 9 here to be next to it. And the reason why it's 1, 9 is because 4 can only be next to 9, and 6 can only be next to 1 on a Whisper 5 line. So that's the reason why we know that. This has to be an orange-pink pair. We have in row 6, 3 greens, so this is 4 or 6 here. We have 3 oranges, so this must be pink left. Since this is pink, for this set of 3 digits, we need an orange here. So this is orange, pink, green, which means this orange, pink, green, orange, pink, green, orange, pink, green, orange. So these are all orange. Pink is the last here. So these are pink. Remaining digit in row 5 is orange because we have 3 pinks and 3 greens. So this is orange, which means 3 away is the other orange. In this upper central box, we have 3 pinks and 3 oranges, so this is green. So this must be orange, pink, green, orange, pink, and green. Okay. Let us see. This cannot be 1 or 9 because of the 1-9 pair in the row. So 1 has to be one of these two digits here. Okay. We know 9's one of these two, so 9 has to be one of these two here. Okay. To surround this quad. Okay. Okay. So these digits must be the same because they're both next to the orange 1-9. So this we're gonna mark these as letters. Oops, I deleted that accidentally. This is going to be A next to the 1-9, the orange 1-9, and we'll mark B as next to the pink 1-9. So next to the on the whisper 5 line. So next to this is A, this is B. B cannot be here. So where's B in this right central box? It has to be here. That means B can't be here and here in the central box, so this must be B there. A cannot be here, so this must be 5, which makes this A for the rest of row 5. That makes this a 5. 5 cannot be here and here in the lower central box, so this must be 5 here. That eliminates 5 here and here, so this is 5 there. That leaves this as 5 there. In this upper central box, 5 can't be here or here, so this is 5. That eliminates 5 from being here or here, so this is 5. That means we also know where A's pretty much are. A can't be here, so A has to be here. And actually, let's just make them all capital A's. We know they're 4 or 6, essentially. So these are B. So this is A with B there. This is B, so that's A, which makes this B, which makes this A, which makes this B, which makes that A. A here makes this B, which makes this A. So that's there. Okay. If this were to be a 9, the problem is that would force this to be 1, and 1 and 9 are not in the same set. So this cannot be 9 here, which means 9 has to be here. So this is 9. So pinks are high, and oranges are low. So that means these are 1. So these are 1. That means these are 9. So this is 1. This is 9. This has to be 9 here. Where's the 1 in this box? It must be here. So that means A's have to be next to the 1, so they're 6. B's have to be next to the 9, so those are 4. Let's see. We have a lot of 1s. So 1 can't be here or here. Where's 1 in this upper right-hand box? It must be there. 1 can't be here or here. In the upper central box, 1 has to be there, which eliminates 1 here and here, so this must be 1 here. That eliminates 1 here and here in this lower left-hand box, so 1 has to be there, which forces this to be 1 here. So we have all the 1s now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We should have a lot of 9s. 9 can't be here or here, so in row 6, 9 has to be here. That eliminates 9 from here and here, so that means 9 is here. 9 can't be here, 9 can't be here in this upper central box, so it has to be here. 9 can't be here and here in this upper left-hand box, so 9 has to be there. No 9 here, no 9 here, so that means 9 has to be here. No 9 here or no 9 here in this lower central box. That leaves 9 as here. And that should be all the 9s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the remaining things we have are whisper 5 lines. Interesting. Okay, so now we're gonna mark these as A and B also, I guess. I don't know. Let's mark this as A and this as B. So we know well, if A and B, this must be next to Z, and Y. So this is Y, so therefore this must be Z. We have Y, Z, Y, Z. So this can't be Z. That's Y, which makes this Z, which makes this Y, which makes that Z. Y eliminates Y here, so that's Z. Z eliminates Z here, so it's Y, which makes that Z, which makes this Y, which makes that Z, which makes that Y. This is Y also, which makes this Z, which makes that Y, and that makes that Y. A and B, this is A, this is B, which forces this to be A. Which makes that B, which makes that A, which makes that B. Which makes this A, which makes that B. Makes that A, B, A. Oh, this is Z. B, A, B, A, B. Okay. So, Z is next to 9. Z is next to B on a whisper 5 line. Z is next to A. So Z has to be next to both A and B on the whisper 5 line, which means it must be next to 7 and 8 on the whisper 5 line. So Z has to be 2. So Z is 2 and Y is 3. A has to be next to both 2 and 3 on the whisper 5 line. So A must be 8 because 7 cannot be next to 3 on a whisper 5 line. So this is 8 and B is 7. And that's a solution. Yeah, pretty straightforward. I really wanted to highlight what happens if you have like the whole grid sort of essentially covered with entropic lines, or yeah, entropic lines essentially, or any type of set where you have one set. You have to have one of each set of 3, right? You're going to run into these restrictions a lot because it's not that restrictive, but it gives you a decent amount of information. So it's not going to be necessarily very hard to solve. Sometimes it can be, but sometimes it can be very helpful, like right here, right? You know a certain amount. I don't know if I would classify this as very easy, though. It's... The logic behind it is simple. But you have to know a decent amount about, like, whisper 5 lines and entropic lines, and I don't know. Maybe my criteria for very easy is too easy. Who knows? Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.